So you're probably wondering why I've got this video that's standing out by itself. This is to highlight a new feature in Revit MEP 2013. In previous releases, plumbing and associated pipework came under the discipline of mechanical. An additional discipline has been added to Revit MEP 2013, and this discipline is for piping. This may seem like a fairly small improvement to the software, but it does mean that whether you're using piping for hydronics, domestic hot and cold water services, sanitary, or fire protection, there is now a dedicated discipline for your views, and they don't come lumped under the mechanical discipline. Let's take a look at that in the project environment and see what the benefits are. From your startup screen, click on Open, browse to your Chapter 11 folder, and open the file Chapter 11 Plumbing Preview. In previous versions of Revit, we were constrained to disciplines of architectural, coordination, electrical, and mechanical. So if we wanted to create floor plans for plumbing or piping, we had to use the mechanical discipline and have a sub-discipline for pipework, whatever that pipework was. And to a certain extent, that still may hold true. Here we have the plumbing discipline with a sub-discipline for domestic, fire protection, and sanitary. We can add as many additional sub-disciplines as we want to suit our particular workflow. From your startup screen, click on Open, browse to your Chapter 11 folder, and open the file Chapter 11 Hydronics. To access the Mechanical Settings dialog box, go to your Systems tab, and from either the HVAC, mechanical, plumbing and piping panels, click on the arrow. It doesn't matter which, as the dialog box is the same for all three. The initial setting we have here is for hidden lines. This gives us the option to cut objects with a hidden line where they cross each other. In previous exercises, we've seen the duct settings. Here we want to concentrate just on pipe settings. For single line ductwork, fittings can be shown at an annotation scale. We can define a pipe size suffix, or if you prefer, a prefix. We have a connector tolerance and also a rise drop symbol annotation size. We can define the default settings for our pipe runs. Here we have hydronic supply using a specific pipe type and its default offset from the current working level. This can be defined for all your pipe systems. We have a similar process for branch pipe work, where we can do exactly the same thing. Select the system, select the pipe type and its default offset. For segments and sizes, we can define the material associated with a particular pipe. Notice here that we can delete or create our own pipe segments. We can assign a roughness and a description. As with ductwork, we have our size catalogue. Although for piping, these are slightly different, as we have a nominal size and then an internal diameter and an outside diameter. Also whether these pipes are used in the size lists that we use, and whether they're also used in our sizing calculations. We have fluids. Here we have water. We can add and delete their temperature, viscosity and density. So for example, if we were working on a hospital and we were placing medical gas pipework, we could create a new fluid for oxygen and put in our temperature ranges, viscosities and densities in the table. Finally, we have slopes. These are the default slope values assigned when we're creating pipe runs. We can delete slopes and add new slopes. In this exercise, I'm going to carry on using the Chapter 11 Hydronics file located in your Chapter 11 folder. Piping systems are how we can define how our pipes not only display in plan, but also react when we're connecting them to equipment. From the project browser, scroll down until you find the Families section. Under Families, we can scroll down further until we find Piping Systems. Here we have specific pipe systems that have the characteristics of the system we're designing. To change it, right-click and click on Type Properties. Here we have the option on how the domestic cold water pipe system displays in plan. We could say that it's blue. We can define a line weight, and if necessary, a pattern. We can assign a material, whether we want to use calculations, and the fluid type running in that pipe. The fluid viscosity and density are assigned by the fluid type and by the temperature. We have our flow conversion methods and also an abbreviation for the system. Here we could add CW for the domestic cold water, and when we place a pipe, if we have the right tag, we can display the abbreviation. For rises and drops, we have considerable flexibility, as we can define a rise and a drop symbol for two-line piping and a single-line drop and rise symbol. And finally for T's, how they display as a single line. So when creating a pipe run, let's scroll up to our plumbing discipline and let's go to Level 1 Piping Plan. If I scroll into the north section of the building and click on Pipe, I can select the type of system, domestic cold water, its diameter, its offset from the current level, and when the pipe is placed, it takes on the characteristics of those we defined for the pipe system. From your startup screen, click on Open, browse to your Chapter 11 folder, and open up Chapter 11 Hydronics. In this exercise, we're going to add mechanical equipment to our model, fan coil units to be more precise. In your project browser, scroll down until you can open up Chapter 3 HVAC Pipe Plan. The fan coil units we're going to place are going to be feeding the south side of the building on Level 3. So the first thing we need to do is scroll in so we can see the south side of the building. From the Systems tab, click on Mechanical Equipment, and from the Properties palette, choose the fan coil unit ceiling ducted CHW and the type 470 litres per second. Scroll in a bit more. At this point, we're not entirely sure which way the fan coil unit is orientated, and we don't really know for sure how high to place it. So from our Properties palette, change the offset to 2800, and then place just one fan coil unit, and click on Modify. Now we can make some changes. Select the fan coil unit in the plan, and we can now see the connections. We have air coming in and air coming out. So we want to feed the offices so that air is flowing in the right direction. The next thing I need to do is find out where this fan coil unit is in relation to the slab above. So let's create a section. From your Quick Access toolbar, click on Section, and we'll draw a section that goes through the corridor and the office that we want to serve. Clear the selection and then double-click on the section head. Now my section was actually going through the 3rd floor, and this is only showing us the ceiling space on Level 2. So I need to select my viewport region and drag it up so I can see where my fan coil unit is located. Let's scroll in, and we can now move it using either the Move tool or the Align tool so that it is hard up to the underside of the ceiling. Using thin lines might help us a bit more, So from the Quick Access toolbar, click on Thin Lines, and now we can align to the face of the ceiling. We can now return to our Level 3 HVAC pipe plan. Now that we have one fan coil unit placed, I can copy this for the other locations that are required. Select the fan coil unit and select the copy tool. In this option, I want to copy multiple times, so click on Multiple from the options bar. Select a base point and then place the multiple copies. Once you've finished placing those copies, you can click on Modify to complete the command. From the Startup screen, click on Open, browse to Chapter 11, and open the file Chapter 11 Pipes. In this exercise, I just want to discuss the difference between pipe placeholders and pipes. And the best way to show this is to change the detail level of my view to Fine. Let's just scroll in to the south part of the building. Here I can create a pipe placeholder. I give it its diameter, its offset from the current level, its pipe type, and the system type, and draw the pipe from one point to another. If I do the same with the pipe tool, check its diameter, its offset, its type, and system type, and draw the same type of pipe, we can see that these pipes look quite different. I can select both of them using a crossing window and change their size. Both of them I can change their system type and their offset from the current level. Looking at the conceptual toolbar, we can apply a slope, we can change the type, we can reapply type, and we can convert placeholder, but that will only apply to the placeholder duct. We can also use the duct and pipe sizing tool. So why bother using the pipe placeholder? If we were to extend the run of the full-size pipe, so let's draw a pipe from that point and create a bend, I'll do the same for the pipe placeholder. The pipe placeholder doesn't contain fittings. This makes it easier to change the design. If I use the Tab key to select the run, I can now pick on this grip and change the run very easily. I can do the same by highlighting a full pipe run, but editing this does start getting harder. You can see that I can't drag the endpoints. And if I select the end of one of the pipes, we start breaking the integrity of our run pretty quickly. The only properties that a pipe placeholder doesn't have in comparison to the pipe is the ability to justify or add insulation. But at the stage of the project we're actually creating pipe placeholders, those particular options are not usually required. From your Startup screen, click on Open, browse to your Chapter 11 folder, and open up Chapter 11 Pipes. There are several ways to create pipe runs, so let's start with the easiest. Scroll into the south end of the building, and from the Systems tab, click on Pipe. I want to specify a diameter for the pipe, its offset from the current level, its type, and the system type. So let's just draw a pipe run that runs around the building and will eventually go up a riser to the rooftop plant room. When I finish the run, press Escape. Another way to start running pipes is to not actually start with the pipework at all in the first place. Let's go back down to that south part of the building. And in this instance, I'm going to select one of the fan coil units. With it selected, I'm going to create a piping system. It's going to be Hydronic supply, and I'm going to give it a name relative to the project. Let's call it Level 3, South Offices, Fan Core Units. Click on OK. I'm now going to edit that system and add the other fan core units to the system. Click on Finish. I can either select the Pipe tool, or I can scroll into my view, select one of the fan core units, and then select the point at which the pipe is going to enter the fan core unit. And I can create a pipe run that will connect into the pipe run I created earlier. Notice how Revit has automatically placed a rising symbol and reducers for the differences in my pipe sizes. Although this is great and how I expect Revit to behave, these reducers aren't really in the right place, and I've got my pipe sizing incorrect, but we can adjust this later on. For this exercise, click on Open, browse to Chapter 11, and open up Chapter 11 Parallel Pipes. At some stage we need to run a bank of pipes that cater for hot and cold water, that could be for domestic, it could be for heating flow and return. You get the idea. Revit has a neat tool for creating these pipe banks, and it's called Parallel Pipes. So let's click on the Parallel Pipe tool and see what happens with the ribbon. On the contextual part of the ribbon, we now have the facility to specify a horizontal number and a vertical number. So let's put 2 in each direction. We can also change the horizontal and vertical offsets. So let's say that the horizontal offset is 300 and the vertical offset is 200. Now I could come down here to my view and select one pipe. That's the easy option, and do each pipe in turn. What I want to do is leverage from the power of Revit and use the Tab key to select the chain of pipes. If I now select, Revit creates the 2 horizontal and 2 vertical pipe runs. Currently we can only see the horizontal, so let's click on Modify and go to one of the sections. Drag that up so we can see high level, level 3, and there's my pipes. Looking at them, they obviously need to be moved down, because I may have a clash going on here. But again, that's an easy task, and we can have a look at coordination in a future video. From your startup screen, click on Open, browse to Chapter 11, and open the file Chapter 11 Modifying Pipes. Make sure from the project browser that you have Level 3 HVAC pipe plan open, and scroll into the north part of the building. So we want to make some changes to our pipe run. Let's see what we can do. If I select a pipe and drag it, it drags any connections with it. I can do the same with the end of a pipe. Revit will modify the pipe and the fitting associated, as long as that fitting can adapt to this angle. Let's just back up a couple of steps and click on the Undo button twice from the Quick Access toolbar. I want to change the size of a pipe, so I select the pipe, and here we can see the size on the options bar. If I go ahead and change this size, Revit will introduce a transition piece at this bend. In the real world, however, that's not what is going to happen. Let's undo that. In the real world, we'd probably have a transition in the middle of the pipe. So from the Modify tab, click on Split Element. We can split the pipe where we choose, then select the pipe we want to change and change its diameter. The coupling that Revit placed when I split the pipes changes to a transition. What happens if I want to change the entire run, however? If I hover over a pipe, I can press the Tab key and that highlights the pipe run. Let's see what happens if I scroll out and find out how much of that pipe run we select. Press the Tab key, select, and I've now selected my entire run all the way around the building. I can press and hold the Shift key to remove objects from that selection set. If I press that down again, you can see a little minus sign adjacent to my cursor. So this is deselecting objects from my selection. If I want to add them, press and hold the Control key and then add those elements. Once my selection set is complete, I can go and change the diameter or its offset. If I want to add to this run, I can select one of my pipes, right-click, and click on Create Similar. Notice how the properties match that of the pipe that I'm selecting. I can now add to my run, and Revit will add a T-piece where required. If I then want my pipe run to either rise or drop from this point, simply select the pipe, right-click on the connector, click on Draw Pipe, and then choose the offset, or type 1. Press Enter, and click on Apply, and our pipe run now rises. Finally, say we wanted to make a fairly substantial change to all of the pipes in this view. Let's take a look at the workflow for that. To do this, I'll open up the default 3D view. From the Properties palette, make sure that we don't have a section box. I'll select the architectural link file and hide it temporarily in this view. Zoom to fit and adjust my view. We can see here the pipes from level 3. Let's go back to the level 3 plan and also open up a section. And now I'm going to tile my views. From the View tab, click on Tile Windows, and I now have 3 views where I can start manipulating the objects. From the 3D view, I'm going to look at the front face. I can select the objects I want to change, then go to my sectional view, click on Move, and move the pipes. Obviously, the more you need to change, the more care you need to take in selecting the objects. From your Startup screen, browse to your Chapter 11 folder and open the file Chapter 11 Sloping Pipes. Check in the project browser that you have Level 3 HVAC pipe plan open and scroll into the north part of the building. Revit MEP gives me the ability to slope pipes, and I can do this in a variety of ways. I can select a pipe and click on Slope. This opens the slope editor. Here I can choose the slope value, the slope control point, and click on Finish. And you can see that Revit has given us a warning. The slope that you specified could not be applied to this pipe. Please check the items that are connected and make sure they aren't constraining the slope of them. What this means is we need to think about this before we go ahead and actually put a slope on a pipe. Let's try that again with a single pipe. So from the Systems tab, click on Pipe, set my offset, check my diameter, and draw the pipe. If I select it, I can put a slope on it. Let's see what's happened to that in section. I'm going to use an unreferenced section, one that isn't used on sheets, and rotate it. And move it so that I can see my pipe. Let's go to the section view, and here we can see the pipe. Let's go back to the plan view. Click back on the pipe tool. If we look at the context toolbar, we can turn the slope. This pipe is going to be sloping up, we can define the slope value, and we can show slope tooltips. What the tooltip does is once you start placing your pipes, Revit tells us the start offset and the current offset. Probably more than any other service in Revit MEP, the sloped piping tool requires the greatest amount of planning. It does work, and it works well. But as you can see here, without planning, we end up getting errors. So we'll try that again. Click on the pipe tool. This time I'm going to ignore the slope to connect. Click on the pipe, start drawing my run, and that's created the pipe with a slope as I'd intended. From your startup screen, click on Open, browse to your Chapter 11 folder, and open up Chapter 11, Adding and Modifying Fittings. We've already seen that it's fairly easy to modify pipes. Let's see if the same is true for fittings and accessories. Scroll into the north part of the project until you can see this duct junction. I'd like to be able to continue this run, so rather than deleting things in here, I can just select the elbow. If I scroll in a bit more, you can see we have these little crosses, and the tooltip shows us that this will create a T. What Revit has done is it's replaced the elbow with a T fitting. I can select the T and now draw a pipe from that position. With that process done, I can also select the T and turn it into a cross. Repeat the process and draw a pipe. And of course, I can do this the other way round. I can select a pipe, delete it, select the cross, scroll in until I can see the minus sign, and turn this into a T fitting. This will only work if these fittings are defined as part of your pipe type. So if I click on the pipe itself, click on Edit, and look at the routing preferences, we'll see that Revit is using these fittings when I'm going through the editing process. So what about fittings and accessories? Let's start by modifying the pipe and splitting it. If I split the pipe, Revit will automatically place a coupling. If I change my level of detail to fine, you can now see the coupling as intended. Click on your Systems tab, and then from the Plumbing and Piping panel, click on Pipe Accessory. If this dialog appears saying no pipe accessory family is loaded, would you like to load one now? Click on Yes. Browse to your Chapter 11 folder and select the gate valve. Click on Open. When I go to place the gate valve, I can either place it on the plan, and you can see here I've placed it. We're on level 3 with no offset, or I can place it in the pipe. Revit splits the pipes for me, places a transition if needed, and places the pipe at the correct level. Additionally, it takes on the properties of the systems. I can change it to another type, which has now removed the transitions, as the gate valve is now matching the diameter of the pipe. From your startup screen, click on Open, browse to Chapter 11, and open the file Chapter 11 Pipe Systems. Make sure from the project browser that you have Level 3 HVAC pipe plan open, and scroll into the south end of the building. We're going to carry on our design by creating some mechanical systems for the fan coil units. When I select one of the fan coil units, we can see the different connectors. We've got supply air, return air, sanitary, electrical, and connections for hydronic supply and return. With the fan coil still selected, from the right-hand end of the ribbon, you can see that we can create systems. And I want to create a piping system. There are several systems here that I can connect to, with one already defined for Level 3 Hydronic Return. Let's give the system a name, South Side Return, and open it in the System Editor. I can now add objects to the system. You can see the other fan coil units are greyed out, but as soon as I select them, they become highlighted. I can do them individually, or I can do a selection window to add the rest. Once I've finished adding fan coil units to the system, click Finish Editing System. I'm now going to repeat that task. Click on Piping again. This time we're creating a sanitary system. Give it a system name, South Fan Coil Unit Drain, and again open it in the System Editor. Again, I'm adding to the system, and I'll do a selection window. Click on Finish. Let's do that again. Select the fan coil unit, and now you can see that because I've connected to all of the pipe connections, we no longer have the ability to create a pipe system. But take a look at the tab on the top of the ribbon. This tab is going to show me the systems that I have selected that are all part of this fan coil unit. We have 3 different systems here: the hydronic supply, the sanitary drain, and the hydronic return. What would be nice, however, is if all these systems had common naming. At the moment, we've got a bit of a dog's breakfast. In other words, a mess. We can change this mess by opening up the Systems browser. Let's remove properties for the time being. Go to my View tab, User Interface, and System Browser. I've got 6 mechanical systems, but what I'm really interested in is the piping systems. There's my hydronic supply, my hydronic return, and my sanitary. If I select the Level 3 South Office fan coil unit system, I can right-click, click on Properties. Here I can select the name and change it for something more suitable. Level 3 South Chilled Water Flow. Click on Apply, and do the same with the hydronic return. Level 3 South Chilled Water Return. And finally, for the drain, we'll call this Level 3 South Drain.